All right, AP Calc, we are back for the second portion of this lesson. This one's all about inequalities, what to do with the basics, the compound inequalities, the ones with quadratic structure to it. What happens if we have, they're called rational functions inside of an inequality with variables on the top and on the bottom. What happens if we have absolute value? Those are going to be the things that hopefully this video will clarify for you guys. So, directions. Solve the inequality and express the solution in terms of intervals whenever possible. So let me show you what that means in the context of number 25. So 25, you've got x times 2x plus 3, and we're setting that greater than or equal to 5. All right, now the first mistake that somebody might make is they might say, it looks like we can just say, hey, make x greater than or equal to 5, and then why not make 2x plus 3 greater than or equal to 5? You technically can't do that, all right, because we need a comparison to 0. A comparison to 0. So it's kind of like in the previous example where we did the quadratic formula, and the factoring one too. Get 0 by itself, create the quadratic structure, and then move forward from there. So I'm going to distribute the x to both parts. That gives me 2x squared plus 3x. And then simultaneously on that step, I'm going to subtract the 5 and move it over here. That doesn't change the direction of the inequality symbol. So then what we have is a quadratic. And we next find the zeros, okay? It's kind of like we want to find the places where this actually equals 0, and then those are going to be critical numbers that we're going to work with. So I'm recognizing right away that this is factorable, so I'm just going to do that factoring. The middle is going to be able to split up into, since it's negative 10, positive 5x and negative 2x would add up to the middle and multiply to negative 10. So I just went ahead and the factoring procedure, I kind of did that quickly. You can do the thing where you make the AC box and everything. But if you can think of it right off the top of your head, just go ahead and move forward like that. So you got minus 5 here, 2x squared plus 5x. I'm just going to do the factoring kind of quickly in this step without explaining myself. We have to take out a negative 1 here. All right, can we see that still? It's still on the board? Yeah. All right, so what this means is that when x equals 1 and x equals minus 5 over divide by 2, that these are critical places that we have to keep in mind. And that's where we set up our intervals, all right? Set up those intervals. It's kind of like when we did our piecewise to absolute value or vice versa, where we set up intervals to test things. See, what we can do now is say, to test the expanse of the number line, negative infinity to infinity, we're going to now start with negative infinity. So you know what? I'm running out of room over here. I'm going to go over to this side of the board. So you had x equals 1 and x equals negative 5 halves. Those are the two spots. We're going to go negative infinity to negative 5 halves. We're going to use a bracket because the whole thing was greater than or equal to. So that bracket indicates that it does include it. The parenthesis indicates that it does not include it. Then we'll have an interval from negative 5 halves to 1, and then 1 to infinity. And your job is you're going to select a point within that region, within that interval. So 2 is between 1 and infinity. 0 is between negative 2.5 and 1. And negative 3 is right there. And what we do is we plug it in to that inequality over there. The x minus 1 times 2x plus 5. When we multiply those together, is it greater than or equal to 0, or is it not? The places where it is, We check that off, and that's going to be part of our solution. So let's see here. This one. So plug in -3. You'd get a -4 times, let's see, -6 plus 1. -6 plus 1 is -1. So -4 times -1 would be a +4. All right, so I'm doing a very informal plug in there. I'm just saying, is it positive or is it negative? If it's positive, it satisfies the condition right here. It says, yes, it is greater than or equal to 0. Therefore, this is going to be a part of our solution. Does 0 work? Well, if I plug in 0 right here, I get -1 multiplied by 0 plus 5, 5. That is a negative number. It does not satisfy the condition of being bigger than or equal to 0. So that does not work. And then when you test 2, it gives a positive here and a positive here. So a positive times a positive is a positive, which is greater than or equal to 0. So my solution, using interval notation, is going to be -infinity to -5/2. Actually, I don't know why I'm rewriting it here. I can just circle it over there. Well, finish what you started, right? So this one checks out, and this one checks out. That's my answer for number 25. All right, let's move on to 27. So similarly to the quadratics, the ones that have like that structure that we just used, if it's a fraction like that, a rational function, you want to get it to one fraction on the left, compare it to 0, and then just have a numerator that gives me critical numbers and a denominator that gives me critical numbers. So I got to move that 2 to the left-hand side. And we're going to do it by subtracting. Now, what I need to do now is create one fraction from those two terms that are being subtracted. So I'm going to put 2 over 1, find a common denominator, which is going to be 2x minus 3. Then that creates x plus 1 on top, minus 2 times 2x, so I'm just going to do that math right now, minus 4x, then it's going to be -2 times -3, which is a positive 6. All that's going to be divided by 2x minus 3, and that's greater than 0. Simplify the top, you get -3x, because that's a 1, plus 7, over 2x minus 3. All right, so again, in the same way, you're using critical numbers to set up your intervals. So whatever makes the top 0 and whatever makes the bottom 0 is going to be used in our intervals on the other side of the whiteboard. So if I set this equal to 0, I get -7 divided by -3, which is just 7/3 or 2 1/3. If I set the bottom equal to 0, you get plus 3 over 2, which is 3/2 or 1.5. Now, when we set up our intervals over here, something tricky happens. If it's on the bottom of the fraction, like the 2x minus 3 was, so here's the 2x minus 3. If it's on the bottom, it's always a parenthesis, because your domain says your bottom can never equal 0. Well, we're using the critical number that made it equal 0. So bottom is always parenthesis. Yeah? And the top, well, the top depends on whatever the sign of the inequality was. So the sign of the inequality was greater than. Now, greater than is not greater than or equal to. The equal to is what makes the bracket. So if it's just greater than, or just less than, you must also use a parenthesis. But like here, you'd use a bracket for whatever the top was for 0. In here, you'd use a bracket for whatever the top was for 0. You would still put parentheses for the bottom critical numbers. All right, do a quick test. 0, this is 1.5, this is 2 1/3. I'm going to use 2. And 3 right here. So the thing we're testing into is this right here. Yeah. So then plug in 0, you get 7 over -3, which is a negative number. So that is not greater than 0. So that's not a part of our solution. Try 2. -6 plus 7, that's a positive number, divided by 4 minus 3, that's a positive number. All right, this is positive, it checks out. So that is a part of our solution set. If you test 3, I think some of you guys already can kind of see, right, it's like, oh, 1 works, 1 doesn't, 1 works, or 1 doesn't work, 1 works, and 1 probably doesn't. This is a -9 plus 7, when I plug that in, so that's -2 over 6 minus 3, positive number. So negative over a positive is a negative. That confirms that it doesn't work. So this is our final answer, 3/2 to 7/3. All right, I'm going to do one of these inequalities because, well, we'll just see what happens here. So that's what's happening with the critical number game. Now you also have situations where inequalities with absolute values show up. And you know what? I'll just stop the video and make that its own so that we can keep these examples split up by concept, nice and clean.